So basic maintenance was one of the main questions submitted prior to this webinar. Before we go into some of the procedures that you can take for your instrument, I'd like to clarify this will be covering procedures that can be implemented by the end user, by the operator. For some specific situations, you might need the assistance from the master service team or the applications team to navigate some of these procedures, and we will be available to assist with them. So I will be speaking just in general terms here. The other thing that I'd like to bring up, some of the parameters that we discuss here are more pertaining to the recent versions of the DMA-80, which is a DMA-80 EVO. For some users that have different versions or different configurations, there might be some other specific parameters that we can walk you through if you reach out to our service applications team. So the first item in this series of good practices is making sure that the flow path of your instrument stays clean. This might even be more critical for users running organic matrices. This includes the sealing rings and the catalyst flange. Any dirt accumulated here can affect the seal of the path. And on one end, it can cause a leak of the gas. And on the other hand, it can lead to carryover issues. So you want to make sure that you are visually inspecting this. If there's something that you see on the catalyst flange, you can simply use a Q-tip with some ethanol to remove that residue that might be building up. The less obvious or less visible part will be the catalyst chamber. As a good measure, you can just simply take a look at it when the unit is not operating to make sure there's no obvious residues present there as well. A common source of potential memory effects has to do with the forks. You'll want to do a visual inspection. If there is any residue, you'll likely want to use a wire brush on them. And I'm stressing lightly and carefully. You don't want to be aggressive on them since they have a built-in temperature sensor. In the case of the newer versions of the instruments, on the DMA-80 EVO, for example, you can run the built-in fork cleaning method, which is essentially a blank run, a method blank that runs the instrument up to 1000 Celsius. Obviously, this will be for specific situations where you're experiencing some, or you are suspecting of some potential carryover issues. Any assistance on this, you can always reach out to us directly. Another widely recommended housekeeping measure is to keep a record of the voltage recording on the instrument screen. It's a good idea to do this at least weekly. Any significant drops can indicate internal issues that might need to be addressed by the service team. This might have an impact on your immediate results, but if they do not, the voltage drop might be an indicator of something coming your way on the performance of the instrument. So by the things that might be required after you see a significant drop, for example, is cleaning the cuvette inside the spectrophotometer. It's something that needs to be performed by our service team. By significant drops, we are talking about 0.25 volts or higher than that. So another important point here, and this might be a more obvious one, is to keep the surfaces of the instrument clean. As I just mentioned, we know that the instrument might be used in a wide variety of settings, anyway from environmental labs to industrial manufacturing facilities. So if it's constantly exposed to dust and other particles, this can accumulate in the electronics of the instrument. This might lead to shorting those components. Also, you want to check that your coils are working properly. The best way to do it is to inspect them periodically to see if there's any deformations. Coils that are not heating properly would affect the recoveries of mercury in your sample. It's also important, and this might be a less obvious measure, it's also important to check during operation for any unusual sounds. This might indicate that the method or the conditions you are using are not ideal. If you hear anything unusual, feel free to contact us for specific assistance on this. All right, so now let's discuss some of the basic troubleshooting questions. Many of these are anecdotal, something that our service and application teams frequently assist our customers with. So the ones that we have here fall under the general category of what can I do if I'm getting poor data. So a frequent question here is what to do with the calibration checks when they're showing higher or lower values. 90% of the time means that they will be showing lower values compared to their expected concentrations. Since often these are performed using a solid certified reference material, one of the first line of questioning that we trigger tends to be whether the material has been properly stored prior to analysis. If it hasn't been preserved per the instructions, this can lead to, for example, the CRM accumulating moisture and therefore showing lower results during the analysis. The second question is making sure that the minimum sample amount is used for the CRMs too. Certificates of analysis, as the one shown here on the right for a dorm 4 CRM, which is frequently used in the field. Those certificates include the uncertainty, or they report the uncertainty within the mercury content. But part of this uncertainty considers a minimum sample amount for representativeness. Smaller sample sizes will increase the relative error on the measurement, resulting in lower or higher results than expected. So if these two sources have been discarded, we can start discussing when the last calibration was performed, and if the sensitivity has significantly dropped, whether the catalyst needs to be replaced. So some users might run tests to determine precision in their measurements as part of their QC protocols, or you might be occasionally running replicates of some samples to check for precision. So let's talk about this parameter. So we know in general terms, you won't be able to achieve good accuracy without good precision. If you see a significant variability in results of your matrices, it's worth checking for some external factors first. Oftentimes, this is whether your balance is calibrated and stable, especially for users working with small samples. Small drifts in the balance will propagate the error and the variability onto your measurement. So I do want to discuss what precision means to us when providing applications or service support. Precision is a parameter that we use internally to determine if your system is working properly. If you're getting poor data, unless there are more obvious cases, we will recommend to run a precision test. This means that you'll run a sequence of 5 boats with a 100 milligram sample of a 0.1 ppm mercury solution. If a precision test is good, regardless of the accuracy that you are observing, this generally means that the unit is functioning properly, and it guides us towards looking into recalibration as a solution, or to explore some other sources that might be affecting this process. So another common troubleshooting line here is when the system is showing high blanks. So here, the most obvious source in case you're running a boat blank will be to look at the boat themselves. If you run a boat cleaning method, this will help address this issue. Now, let's say that you already checked for this. We discard this as a source. There are 2 other sources of potential high blanks, and this has to do with either the consumables or the physical components within the flow path. So the easiest way to see if the consumables are contributing to this is to run a test. So let's say that you had a sample that had a significantly high mercury content compared to what you normally process. This might increase the baselines of mercury that you see coming off as a blank. Newest units will have the auto blank feature, and that can help address this during operation. But sometimes you can accelerate this if the blanks are coming off significantly higher and they're affecting the performance of your unit. To test this, we traditionally have used a nitric acid boat. This means we're running about 100 microliters of 7 to 10% nitric acid. More recently, we've used HCl, which gives just as favorable results by using less acid. It's basically the same procedure, but using 2% ACL. If you run this and the issue persists after running 2 or 3 instrument blanks, we can start looking at other sources. That includes the forks, the catalyst flange, and the chamber. If, for example, you ran these high samples with high mercury content, some of these might have been accumulated on these components. At that point, we'll walk you through the measures that we discussed previously as far as cleaning those residues. And otherwise, if we determine that you need more direct service support, we'll definitely connect and make that happen as well. The other last topic here to cover is what happens when you are hearing popping sounds when you process a sample. This means that you are, this likely means that you are processing large sample sizes of reactive matrices. So we discussed what we can do in terms of adding additives to the sample vote to mitigate this, to provide this surface area that will control for the combustion. The other natural step will be to reduce the sample size. The systematic way that we do this is we'll just give you a baseline of the sample amount that you can use. And we'll progressively walk you through how to make small additions until you see that this effect does not show. And if you have the need to increase that size, we can check what we can do in terms of adding those additives too.